talk about graphing of linear equations. Let's start with just regular graphing. This type of graphing that we do, where we have one line going horizontally, which we call the x-axis, and one line going vertically, which we call the y-axis, is called Cartesian coordinate graphing. And the word Cartesian actually comes from the name of the mathematician that came up with this type of graphing, whose name, he was a French mathematician. His name was René Descartes. And as a result of this innovative way of putting things on a graph, the name was of the graphing was used, his name. You see the carts from the Descartes in his name. So that's what the name stands for. Now, I know my thing is a little bit, I'm having a little bit of a problem because when let me see if I can get this to somehow I don't know why it's not, maybe it's my, trying to make it so it looks straight. Okay, this is supposed to go straight across, this is supposed to go straight down. And every point in this plane, this flat surface, let's call my board the plane, is going to have two numbers associated with it. It's called an ordered pair of numbers. So pair, everybody knows a pair means two. So there are going to be two numbers here. And the fact that it's called ordered means that the order in which I give you the two numbers is very important. And I'm going to write it something like this. Let's say I'm going to write 2, -1. These are two numbers. The first number always stands for what we call the x coordinate. It's telling us how much we should go in the x direction. Now the x is the horizontal direction. I always start counting from this point where they two meet, which is called the origin. And this is telling me to count 2 points from the origin going, since it's the first number, in the x direction. So it's a positive number, so I'm going 2 here. That's first. The second number is the y coordinate, and that tells us how much up and down to go. If it's positive, we go up. If it's negative, we go down. So then from here, we go down 1. And this point, 2, -1, is the point that we're talking about. Notice it took me 2 steps. I had to go 2 to the right and 1 down to get to that point, but it talks about 1 point. Each point has 2 numbers associated with it. And every single point on the graph has a set of points, a set of numbers associated with it. And every pair of numbers is associated to a point. For example, the origin has the coordinates 0, 0. When I talk about the word coordinates, I mean the numbers that tell you how to get to the point. And very often I'll talk about the point 2, -1. Now, you can say 2, -1. 2, -1 isn't a number, isn't a point. 2, -1 are two numbers. But since from the two numbers, I can figure out what point we're talking about, so I sort of use sloppy language, shall I say. Really, I should say the point associated with the two numbers 2, -1, but it's just easier to say the point 2, -1. And everybody understands that that's what I'm doing. let's say I went to this point. 1, 2, 3, 1, 2, 3, 4. Anybody want to give me the coordinates of this point? I went 3 to the left and 4 down.
So I believe that that is 3 to the left, huh? So that's -3. And then you went how many down?
4.
4 down, so -4.
Right. Perfect.
And then each quadrant has like its rules, right? Like since they're both negative, like if it's in that quadrant, I should assume that both of them are negative, right?
Right.
Okay, that's what I remember.
I didn't talk about what but since you mentioned it, if you notice, the way we drew it, we drew the whole area was broken up into 4 parts. Each of these parts is called a quadrant. We start counting the quadrants from the upper right-hand side, and we go counterclockwise. So this is our first quadrant. This is our second quadrant. This is our third quadrant. And this one is the fourth. And it's what Emma mentioned, that you can tell what quadrant a point is going to be by looking at its signs. In the first quadrant, both the X and the Y are positive. In the second quadrant, the X is negative because we're going to the left, but since we're going up, it would be the X negative, but the Y positive. In the third quadrant, the X and the Y are both negative, whereas in the fourth quadrant, the X is positive, but the Y is negative. So you can look at the points and actually tell what quadrant it's in without really doing the actual graphing of it, just by looking at the signs.
Professor, I have a question.
Sure.
It's Jennifer.
Yeah.
You see where you went to the right on the X that we marked 2, and then you went down 1,
Right.
-1. So we would have to graph it under the 2. You see how it's, because the word origin is there, so I'm a little confused if it's that we're supposed to.
Yes. To say 2, -1 means you first go 2, and from
then
the
go
2,
down
you
1.
go down 1.
Okay.
That's why you need, but notice it's only the 2, -1, even though it's 2 numbers, means 1 point. It doesn't mean a 2 here and a -1 here, which I see sometimes people do. They think they're 2 numbers, it must be 2 points. 2 numbers means 1 point. Is that clear? Okay. So now I think we're okay. Does anybody have any question about this before I go further? Okay, so then this is how we work with points.
Could you go over it again, please, Professor?
Sure.
All right, thanks.
Okay, let's do 2 more examples. First of all, I'm going to go to this point. 1, 2, 3, 1, 2, 3, 4, 5. Okay, I found a point. What are the coordinates of that point?
3 and 5.
Okay, that means I have to, and the way I write it is parentheses 3, comma 5. And I have to put in the parentheses to indicate what I'm talking about is a point, because if I just write 3 and 5, you're not going to know what I'm talking about. This, putting it in parentheses, the first number then always means the number to the right or left. The second number always means the number up and down. Okay, let's go to this point. What if I went over here and I went over here? What would that point be?
-2 and 1.
Right, that would be the point -2, comma 1, because we're going 2 to the left and 1 up. Okay, let's go further. What if I give you the point -3, +1? Where would that point be?
In the top left.
Okay, but where? What do I do?
It's -3, so go to the -3 on the line,
Right,
and then it's positive what?
1.
Positive 1, go up 1. Boom.
This is the point -3, comma 1. Where is the point 3 minus 1? Where's that point?
On the right-hand side,
Right, I have to go on the right-hand side, how far?
3,
And then,
up 1 to the negative side.
what do I do with the negative
Oh,
1?
down, sorry. Down 1.
Down 1, right. So that would be right here. So notice how important this is. And I'm only doing whole numbers, but this could be fractions and decimals. Like I could give you 3.3. Now that would be very hard for us to graph actually, but we would know it's like between 3 and 4. So any real number, both positive and negative for the X and for the Y, that fills up this whole plane. Is that clearer now? Who'd asked me the question originally?
Yes, thanks.
You're better now?
Yes, thanks.
Okay. So now I want to go from points. A point is probably the simplest building block of shapes. But once you have points, the next simplest building block is a line. How do we graph a line? So it turns out that when we have an equation that has has either x's or y's or both, but doesn't have any x squares or any y squares, just a plain x, just a plain y, it's what we call a first degree equation. The highest exponent we're going to see in this equation is 1. That type of equation is the equation of a straight line. And we're going to look at straight lines and see how can we graph these lines. How can we graph, if I give you an equation, today we're going to start that way. If I give you an equation, how can you graph the line? And we're going to talk about some of the features that we're going to see on these lines. And then on Thursday, the next step is going to be, what if we know what our line looks like? I have a picture of a line. Can I find its equation? So these are two opposites, just like what we were doing with points. First, I gave you a point and asked you the coordinates and asked you to find the point. But I also did the opposite. I gave you a point and said, what was its coordinates? So you should be able to go backwards and forwards with both points and now with lines. Now, as we said, these first degree equations are very often called linear equations. And I think it should be obvious, the reason it's called a linear equation is because it gives you on the graph, a picture of a line. The word line is right in it. It's also sometimes called a first degree equation. The degree of an equation is the highest exponent you see on your variable. We will have basically two variables. The highest degree means, the first degree means that the highest exponent we're going to see is 1. Yes, Emma, you had a question?
No.
Oh, I thought you were starting. Okay. Now, there are two ways we often see these equations written. One is called the standard form, and one is called the slope intercept form. These are the two most common formats for these equations. In the standard form, you're going to have something like this: 3x minus 2y equals 6. This is an example of a linear equation in standard form. How do I know it's a linear equation? Because my x has an exponent of 1, my y has an exponent of 1. If there's no exponent there, it's understood to be 1. It's in standard form because in standard form, we have the x's, the y's, the equal, and a number. That's how it's set up. X, Y, equal number. And usually there are no fractions in it, it's just whole numbers. That's how a standard equation is written. So the question is, if I give you a linear equation like 3x minus 2y equals 6, how do we go from that equation to drawing the line? I'm going to erase all this other thing so that we can do it on our graph. And I'm going to show you what I call the easiest way to do this. The easiest way to do it is by a method that I call the intercept method. What do we do? The whole point is, let's think about how can you get a line? How many points do you really need in order to get the picture of a line? Anybody have any guess? Is 1 point going to be enough?
No, 2.
You need 2, right? Because once you have 2 points, like if I have 1 point here and 1 point here, then of course I can draw the line. I just have to take a ruler. I can't just use 1 point because I could go any which way. But once there are 2 points, you can draw the line. So, and the easiest points to usually find on a line is something called the intercepts. There's an x-intercept, and there's a y-intercept. The word intercept means cross. X-intercept is the point where the line is crossing the x-axis. The y-intercept is the point where the line is crossing the y-axis. Now let's think about a point. What do we know about the points on the x-axis? The x value could be any single number, but the y value has to be what? What does the y value of a point on the x-axis have to be?
Negative?
Does it have to be negative? Let's look at this point. What is this point? Let's take points on the x-axis.
Oh, that's 0, right?
Right. What's the x?
1, 2.
This is 2, comma,
0?
0, right?
Oh, okay.
We're not going up or down. What about this point over here? What is this point?
That's -1, 0.
That's the point, -1, 0. In other words, in order for something, I'm gonna just erase this and I'll come back to it. In order to have a point on the x-axis, the y value has to be equal to 0. So what I do in my equation is to find the x-axis, I set y equal to 0. I know that the y has to be equal to 0 in order for it to be on the x-axis. Well, let's look at our equation. Our equation was 3x minus 2y equals 6. So remember, we want to find where the y is 0. So I'm going to go to that equation, and wherever I see a y, I'm going to put 0. I'm going to replace, to find the x-intercept, we're going to let the y equal to 0. And then we can solve the equation because now we'll only have x in it. 3x minus 2 times 0. Well, 2 times 0 is 0, so this is just 3x equals 6. And that's easy to solve. And I get x equals 2. In other words, in this equation, when the x is 2, the y is 0, and therefore 2, 0, or the x-intercept is 2. The correct way to say the x-intercept is say 2, 0. But if I just say that the x-intercept is 2, that's clear, because if it's going to be an x-intercept, the y has to be 0. So sometimes instead of saying the x-intercept is 2, 0, sometimes we just say the x-intercept is 2. But we understand that the y is going to be 0. And I've now found one point on the line. Okay, but I know I need another point. So let's find another point. Another point that's quite easy to find is something called the y-intercept. Think about the y-intercept is where the line is crossing the y-axis. And just like all the points on the x-axis have their y value equal to 0, all the points on the y-axis have their x equal to 0. Let's look at this. What is this point? What is the coordinates of this point? I went up 2 and stayed right there.
Zero, 2.
Yeah.
Is it 0? It's 0, 2. Perfect. 0, because the first number gives us how much right or left we're going from this point, and we're not going right or left at all. The second point tells us how much up or down we're going, so this is the point 0, 2. What about this point down here? What is that point? I went down 4 on the line. Anybody?
0
4
minus 4.
I
0
0
minus
negative
Or
3.
0?
0, negative
4.
4.
Negative
Perfect.
4.
Right, because we didn't go left or right at all, so that's the 0, but we went down 4. So it's clear that on the y-axis, all the x values are 0. So to find the y-intercept of the line, instead of putting the y equal to 0, we put the x equal to 0. And when we put the x equal to 0 in our equation, we're going to get 3 times 0, because we were letting the x equal to 0, minus 2y equals 6. And 3 times 0 is 0, so I don't need that. And I get negative 2y equals 6. And that gives me that my y equals 6 divided by negative 2, negative 3. My y-intercept is negative 3. Now, really, the correct way of writing that is to say the y-intercept is 0, negative 3. But just like by the x-intercept, we know the y has to be 0. By the y-intercept, we know the x has to be 0. So sometimes instead of saying the y-intercept is the point 0, negative 3, we just say it's the y-intercept is negative 3. That means on the graph, we have to go down 3 on the y-axis. Now here are 2 points. Here was our point 2, 0, which was the x-intercept. Here's our point 0, negative 3, which turned out to be our y-intercept. And now I can just draw the line because I have 2 points. Here's my line. So this is what's called the intercept method of graphing a line. Don't forget, if you want to find the x-intercept, you put the y. It's just the opposite of what you think. To find the x, you put the y equal to 0. To find the y-intercept, put the x equal to 0. Okay, let's see if you can do a problem like this. I'm going to give you one to try. Can I erase this so I can give you one to try? And while you're trying this, I will take attendance. Okay. Okay, on your paper, I want you to try graphing this line. 3x plus 5y equals 15. See if you can draw a sketch on your paper of the line. It's in a standard formation because it has the x, the y, and the number. Find the x and y intercepts and sketch the line. Okay, so how am I going to find that?
So if y equals 0, then
Okay, we're finding the x-intercept by putting y equal to 0. And what are you getting?
I did 3x and 15 by 3.
3x.
And 15 by 3.
Okay. Since the y is 0, that's why these are easy to find, by the way. It's easy to find the x and y intercepts because when you replace a number, a variable by 0, it really disappears. So all you're really left with is 3x equals 15. So that's why he's telling me divide everything by 3 and you get x equal to?
To 5.
Right. So my x-intercept, which we find by letting y equal to 0, is 5, or better yet, 5, 0. But again, I will totally accept you're saying the x-intercept is 5, but the really technical correct way to say it is that it's the point 5, 0, which is where, what do I do to find that point? Corey?
So for x, it's going to be 5 going on the right side.
Okay, so we're going 5 to the right on the x-axis, and it's this point right there. Okay, now what did you do?
On the y-intercept.
Right, so you want to find the y-intercept, and how are you going to do that, Corey?
So with that one, x with x equals 0.
Right, we're going to replace the x with 0, which means the term that has the x in it, we don't see at all. It disappears. 3 times 0 is 0. It's not affecting us. So what are you left with?
I divided 5y by 5.
Okay, so you had 5y. You don't have the x, so you just have 5y, and that's equal to 15. So you divide it by 5. And what did you get y equal to?
0, 3.
Okay, so you got your y equal to 3, which meant your y-intercept is 0, 3. Perfect. Again, if you said the y-intercept is 3, it's acceptable because you know it's on the y-axis, and that means that the x is 0. So that's right here. And then you just connected those 2 points. How many people have? I got a line that looks approximately like that. Your line should slope down this way. It should.
I got that, but I think I was confused by the question because I put both like 5 and I just put 5 and 0 and 0 and 3 as the answer, but all we're finding is where the y-intercepts.
We wanted to draw the line.
Yeah. Okay, that makes sense.
Okay, so you wrote what the intercepts were, but you didn't go to the step of actually drawing the line.
No, I drew the line. I don't think I was understanding what you were asking.
Okay,
but I do now.
You okay now?
Mm-hmm.
Okay.
Thank you.
All right. Now, another way Does anybody have a question about this here? Okay, then if not, let's go on to the next thing. There is another way in which linear equations are written. And I want to talk about that way and talk about what it means and how we go about using that other method. This was what we called the intercept method. Let's look at the other method. And then maybe we'll come back to one of these equations that we did, and we'll do it also by the other method.
Professor,
Actually, yes.
did you mark Ashley Ortiz present? Because she says that her mic isn't working.
I did, because I saw she had sent in a chat before, so I knew she was here. I marked her present. Thank you, Jennifer.
No problem.
You're keeping me on my toes, and I appreciate it. I really appreciate it. I love this class because I don't feel like I'm talking to a wall. I'm really talking to real people who are part of the, and I know if some of you have trouble with your marks and whatever, if you can't, okay, you can always send me a text or something of that nature. Okay, so what do we want to talk about? We want to talk about something called the slope intercept method of graphing a line. Now, these are really the only two methods I'm going to be talking about, though there are other methods. These are the methods that are easiest to deal with, and therefore the ones I'm going to be talking about. Let's say I gave you an equation that looks like this. Y equals 1/2 x minus 3. You might have heard this being called the y equals mx plus b form of the line. Have you ever heard that term, y equals mx plus b? That stands for the slope intercept form of the line. You get that format when your equation says y equal. Notice in this equation, in the standard form, we have both the x's and the y's on one side, and the equal sign, and then a number. In this case, we have the y standing all by itself, and then we have something times the x, and then something. And depending on what that number, the coefficient of the x is, and what the number that stands alone that's not connected to the x, that will tell us information about something called the slope of the line and the y-intercept. Now, the y-intercept, you understand what it means because we just talked about. When we talk about the y-intercept, we're talking about where the line is crossing the y-axis. In the y equals mx plus b form of an equation, the m is a slope. So for our particular equation, the slope is 1/2 because that's the number that's in front of the x. I'll talk about what that means in a second. And the b, and don't ask me why they picked m and b, I don't know. It's just that's the standard letters that are used, so we will stick with it. The b is the number that stands alone. That's negative. That's what we call the y-intercept. And for our particular equation, it's -3. Notice I don't just say 3, but it's -3 because the sign is part of the number. Now, we already understand what we mean by the y-intercept, so let's put that on our graph. If our y-intercept is -3, that means that's really the point 0, -3. So I don't have to write that. And I just know that I go down 3 on the y-axis. But that's only one point. How do we get other points? Well, that's where the slope is going to help us. The slope is something called rise over run. What that means is the slope, you know what a slope means? It tells us how much something is slanted. So if the slope is 1/2, that means that you're rising 1 and running 2. Rise means going up or down. If it's positive, you're going up. If it's negative, you're going down. And run means going positive is to the right, negative is to the left. This is a positive number, 1/2. So therefore, my slope being 1/2 means that I'm going to be going up 1 and 2 to the right. But from where? From where do we do this rise over run? We have to do it from another point on the line. And the only point that we know on the line this far is this point. In other words, I start by plotting the y-intercept, and from that, using the slope to get to another point. Rise 1, here, I'm over here, I rise 1, run 2. Here's my second point on that line. What if I wanted, that's really all I have to do, but I could do a third point or a fourth point. Again, how would I do another point? By again, rising 1, run 2. And again, rise 1, run 2.
You rise 1 because of the half you round up.
The numerator on the slope tells you how much to go up. The denominator tells you how much to go side by side.
So it's always going to be a fraction?
No, if it's not a fraction, then you have to put it over 1 to make it into a fraction.
Copy.
Because you have to know what's the rise and what's the run. Notice I now can draw my line because I now. Should we try another one?
I would like to.
Okay. So let's go over here. And actually, let's look at this problem that I gave you before. I'm going to go a step further. I knew how to solve this, how to graph this, using the slope, using the intercept method. But I'm going to show you how we can transform something from the standard form to the slope intercept form and use that to graph our line. That's something I happen to like, the slope intercept method. That's my preference. So what I usually do is I go and I transfer and I make every equation, every linear equation from, even if it's in the standard form, into what we call the slope intercept form. So how are we going to transform this into the slope intercept form? Whenever you have an equation, to put it in the slope intercept form is you have to get the y by itself. So think of everything else in the equation being numbers and the y being your variable. So if I want to solve for y, if I want to get the y alone, the first thing I have to do is get rid of this 3x. Now this is a positive 3x, so I have to subtract 3x. This is just like we did with the equations before. Now, when I subtract the 3x, that gets rid of this, and I'm left with negative 2y. What happens on the other side? Well, I have a 6 and a negative 3x, and they're not like terms. So I have to keep them separate. It doesn't matter if I put the 6 first or the negative 3x first, but usually in the slope intercept form, we always want the x term to be first, so I'm going to write that first. So I'm going to write negative 3x plus 6. It wouldn't have been wrong to write 6 minus 3x. It just wouldn't be in the format that I wanted. So when I do this transformation, I'll always get the x term first and then the number. And I'm almost there, except I have a number in front of the y. I have a coefficient of -2, so I'm going to have to divide by -2, which means I'm going to have to divide every term on the other side of the equation by that same -2. That will give me y equals, well, a -2 divided by a -3, well, a negative and a negative is positive, is 3 over 2x. And 6 divided by -2 is -3. I have transferred from the standard format to the slope-intercept format. Does anybody have a question as to how I did that? Now, I'm going to graph this using the slope-intercept method. I don't have my original, but you might look on your papers and you're going to see the line will look exactly the same.
I have a question.
Sure.
This is Kashira.
Kashira, yes.
You see where the x is at? Is it possible for the x to be a decimal or no? On -3x over -2.
Okay, and then when you want to graph, you really don't want to work with decimals. You want to leave it as fractions. Because remember, the slope always stands for rise over run. So it's much better to have it as a fraction. It's not wrong, but if you left it as 1.5, which is what you probably got, then you'd have to put 1.5 over 1, and then you'd have to rise 1.5. It would be correct, but it's easier to do it when you have whole numbers and as a fraction. Is that clear?
All right.
Okay.
Thank you.
So let's see how we would graph this line using the slope-intercept. We always start with the y-intercept. What did we say the y-intercept is? Let's look at it. The y-intercept is a number that stands alone. So therefore, your y-intercept is going to be -3, which is what we had found out when we did it over here and we found the y-intercept. We go to that y-intercept, which means on the y-axis, we go down 3. And from there, we use our slope. What is our slope? Well, the slope is a number in front of the x, the coefficient of the x, which is 3 over 2, which tells me that from here, I have to go count up 3, 1, 2, 3, 1, 2, 3, and then count 2 to the right because these are all positive, and here's my second point. If I want a third point, and sometimes I do, I don't need to, I could again count up 3 and 2 to the right. I can do this a million times if I really want to. Here's my line. Notice the advantage of the slope-intercept form is that you're not stuck with just 2 points, but you can have as many points as you want by keep using the slope to go from one point to the next point to the next point. Okay, are you ready to try one like this? I'm going to give you a couple minutes. I'm going to give you a problem. Unless there's any questions. Does anybody have any questions? Okay, so here's a question for you to try. I'm actually, this is number 7 on their practice sample sheet. It says graph the equation of the line using the slope and y-intercept. And the equation is 2y minus 5x equals -20. They're giving us, it's not even in the standard form because it doesn't, it has the y first and the x, but it doesn't matter. What they want us to do is put this in the slope intercept form and then use it to graph the line. Okay, I'm going to give you a few minutes to try that. Okay, is there anybody who wants to volunteer to walk me through this? No volunteers?
Wait, can we get 1 more minute?
Okay, sure. Walk me through it, or you want me, should I do this because somebody said they're confused, so maybe I should
I
do it
can
myself.
try, but I don't know if I'm right.
You know what, let me do this.
Yeah.
I think I better do this one, just because there seems to be not complete understanding, so let's see if I can do it. I want to write this in the slope intercept form. The first thing I have to do is get the equation so it's y equals. That's number 1. So the first thing I want to do is get rid of this -5x. I have to bring this 5x to the other side. So I'm going to write add 5x to both sides. Or if you're using the transposition form, this is a -5x, you bring it to the other side as a +5x. This will give you 2y. This we're getting rid of. And we have a -20 and a +5x. And because we always want to put the x term first, it doesn't matter which one in terms of actual working out, but because we want it in the slope intercept form, we want to put the x term first. So the 5x is going to be first, and then the -20. And the only thing that I'm left to do is then divide by the number in front of the y. The coefficient of the y is 2. I have to divide every single term by 2. So that'll give me y equals 5/2x, because that can't be reduced, and -20/2 is -10, which means that my slope is the number in front of the x, which is 5/2, and the y-intercept is the number that isn't attached to the x, which is a -10. Any questions about that? Okay, so now how do we go from what the slope and the y-intercept is to drawing the line? So whenever I'm graphing a line using the slope intercept form, this is my number 1 step. Go to the y-intercept. The y-intercept is -10. That means on the y-axis, I have to go down 10 steps. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Here is my y-intercept, my first point. Now I'm going to use the slope to get to other points. What does the slope tell me? The slope is 5/2. That means my rise is 5 and my run is 2. The number on top is always how much up and down you go. The number on the bottom is always right to left. So I have to go up 5 from this point, not from the origin, but from your y-intercept. 1, 2, 3, 4, 5, and then count 2 to the right. 1, 2. That gives me a second point. If I want another point, I don't have to, I could just draw it, but if I want another point because I want to be more accurate, then I can go again up 5, 1, 2, 3, 4, 5, and 2 to the right again, which will get me right here. No, it'll get me, no, I messed up. It shouldn't. This should have been here. I'm looking at it. It's right here. And here is my line that I wanted to draw. Does that make more sense to you now?
Yes.
Yeah, okay.
Yes.
A little bit more. Yeah.
Let me just, I want to do one more before I go into anything else. I want to talk about what happens. All of these lines happen to have slopes that were positive. Let's look at a line whose slope is negative. What if I gave you this equation? Y equals negative 2x plus 3. Now it already is in the slope-intercept form because it says y equal, which means that the slope, or m, is a number in front of the x. What is that number? What is the number in front of the x?
2, negative 2.
Negative 2.
Negative 2.
But it's not a fraction, so what should we do with it? We want the slope to be a fraction because we need it to be rise over run.
Be negative 2 over 1, correct?
Right. So any whole number you
You
put.
gotta solve x or no?
What? I'm sorry. Repeat your question.
Hmm?
I didn't hear your question. I'm sorry. Something about X, but I don't know what you asked.
Oh, no, never mind, never mind.
Okay, good. The y-intercept is the b is equal to 3. Okay, so anytime you don't have an actual fraction in front of your x, your coefficient of x is not a fraction, just put it over 1 because you have to have it written as a fraction. Now, how do we graph this? Now, this is where we have to be careful. My y-intercept being 3 means I'm going to be starting at 1, 2, 3, right here on the y-axis. There's my y-intercept. That's my starting point. How do we use our slope? Remember again, our slope is rise over run. Now, here's the problem. There is a negative here. Generally, when a fraction is negative, the easiest way to handle it is to keep the negative in the numerator. Even if I have something like 2 over negative 3, let's say, that could be rewritten as negative 2 over 3. You don't like dealing with a negative in a denominator, and you can always change the negative and put it. These all mean the same thing. 2 over negative 3, negative 2 over 3, or even a negative in front of the fraction. One negative in the fraction can be in the denominator or in the numerator or right in front. They all mean the same thing. And for graphing purposes, it's easiest to have the negative in the numerator. And that's what I have over here. I have negative 2 over 1. That means that my rise from this point, from my y-intercept, is negative 2. Well, a rise of negative 2 really means go down to 1, 2, run 1, go 1 to the right. You could go again down to 1, 2, 1 to the right. And you get a line that looks like this. And I think it's clear that before all our lines were slanting up. As I went from left to right, if they had positive slopes, they slanted up. If you have a negative slope, your line, as you go from left to right, is slanting down. So the sign on the slope clearly tells you whether your line is rising or falling as you go from left to right. Don't think this is a rising, because when you go this way, we're always, the correct way to travel is from left to right, and this is going down. Okay, so there's two other things I'd like to do today to talk about. There are two special lines that we haven't talked about. And number two, can we find the slope of a line? Can we find the slope of a line if we don't know the equation of the line, but we just know 2 points? And I think that's what I'm going to start with first. Sometimes I might be given 2 points on a line. Let's say the points are 3, 5, and -2, -6. Here are 2 points. Now we know when we have 2 points, we could draw a line. Let's draw the line. That means my first point is 3 to the right, 5 up. And my second point is 2 to the left and 6 down. And since they're 2 points, I can connect them. And here's my line. I don't know the equation of this line. I don't know the slope of this line. Actually, next time we're going to talk about how do we find the equation of the line. But today I'd like to talk about how do you find the slope of that line. Now, one way you could do it is by counting points. Because remember, slope is rise over run. So if I start at the point that's on the left, I always start at this leftward point, I could count how many boxes I have to go up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I have to rise 11. And now I have to see how many points I have to go to the right. 1, 2, 3, 4, 5. I'm going 5. My slope should be 11 over 5. Now, the problem with it is if you have graph paper, and that's why really if you're doing this on Delta Math, then it's easier to count the points. If not, you should do this on graph paper because then it would be really easy to count the boxes. If you're doing it just on regular loose leaf paper, you're not going to be able to count the boxes as accurately. And you might make a mistake. So there is another way of finding the slope of the line by something called the formula for the slope. The formula for the slope is m equals y2 minus y1 divided by x2 minus x1. y2 minus y1 means the difference between the y's. x2 minus x1 means the difference in the x's. Here are my 2 points. You can pick any one to be your x1 y1. And the other point then becomes your x2, y2. These numbers, these subscripts are just telling you x1 means it's the x of the first point. The y1 is a y of the first point. Once you pick this as your first point, this becomes your x2, y2 because this is the x of the second point and the y of the second point. Don't mix them up. Once you call this your first point, this has to be the x1 and the y1. You can't have an x1 with a y2. x1 goes with y1, x2 goes with y2. It doesn't matter which you call your first point and which you call your second point, but you have to be consistent. In your formula, stick in the number. According to me, my y2 is -6. My y1 is 5. So this becomes -6 minus 5 on the top. My x2 is -2 minus my y1, which is 3. And now I just have to do the arithmetic. -6 minus 5 is -11. -2 minus 3 is -5. Once I have a negative over negative, I simplify it to a positive. Negative divided by negative is positive. And again, my slope comes out to be 11/5. My rise, which is exactly what I did by doing rise over run. It's more accurate because I don't make a mistake in counting those points, those boxes. All right. Are you ready to try one on your own?
Yes.
Okay.
This formula is only when we have the numbers in the parentheses, right?
Right, when you have the points. Okay, so now we learned 2 ways to find slope. One is when you have the equation of the line, the y equals something times x times something. Then it's a number in front of the x. But if you don't have the equation of the line, you just have the actual point, this is the formula you use to find the slope. So depending on the circumstances, that's what you're going to do. Okay, so let's say I give you the 2 points, -2 minus 1. And -3, -4. Those are my 2 points. It doesn't matter what you call your first and what you call your second. I'm giving you a few minutes to figure out the slope of the line. Find the slope of the line. I'm going to do this one because you have to be careful. Now, I always like to pick one as my first. I like to label it. First point and second point. It doesn't matter what you call your first point. Let's call this our first point. So this would be the x1, y1. And this is our second point. So this is the x2, y2. So according to that, the formula is y2, that's -4, minus y1. So it's minus -1. Be careful that there are 2 negatives here. And the x's are 3. My x2 is 3 minus -2. Be very careful with your signs. Everybody clear as to what I've done so far? I did y2 minus y1, so that was -4 minus -1, and x2 minus x1, so that was 3 minus -2. Now remember, when you have 2 negatives, 2 negatives become a positive. This becomes a positive. The same thing over here, the 2 negatives. A negative with a negative. When you multiply a negative by a negative, you get a positive. So this is actually -4 plus 1, which is -3. And this is 3 plus 2, so that's 5. So your slope actually is -3 over 5. Don't think that I saw a few people did -1 minus 1. They just did -5. You have to, once you have two negatives, it becomes a positive. So make sure you're doing your signs correctly. Want to try another one? Can we
Yeah,
try
sure.
one more?
Yeah.
Yes.
So let's try one more. Again, just be careful. Let's say the points are 5, -6, and 2, -4. See if you can find the slope of this line. I'll give you a couple minutes again. Okay, somebody want to get me through this?
I can do it.
Who's that?
Jonathan.
Okay, Jonathan, I'd love you to do this. Okay.
So what those two numbers are the x1, y1,
Okay, you call this one x1, y1.
and x2, y2.
Perfect.
Then I implemented the formula, which was y2 minus y1 over x2 minus x1. And it would be -4 minus -6 over 2 minus 5.
Okay.
Then I got 2 over -3.
Okay, how did you get 2?
Because -4 minus -6, it turns to a positive.
Right, this becomes a positive, and two negatives make it a positive.
So -4 plus 6 equals 2. And then 2 minus 5 equals -3.
Right. And 2 over -3 is a perfectly good way of writing it. You could also write it as 2 negative in front, -2/3, or you could also write it as -2 over +3. They all mean the same thing. When you have a negative in a fraction, it could be in the numerator, it could be in the denominator, it could be just in front. Notice when you have a negative in front of a fraction, it means either the numerator or the denominator is negative. It doesn't mean both, because if they both be negative, it would be turned into a positive. So this is, if you gave your answer in any one of these ways, you were correct. Thank you, Jonathan. That was beautiful. Okay. I'm just going to mention just one other. Two special lines. Two lines that we haven't sort of taken into consideration yet. So all the lines that we've been talking about have been slanted lines. What do I mean by slanted lines? Either as you're going from left to right, you're going up, or as you're going from left to right, you're going down. And most lines that we deal with are slanted. But every so often we have lines that go straight across or straight up and down. Let's say I have this line over here, a line that's going straight across. It's what we call a horizontal line, going straight through 3. Let's look at some of the points that might be on that line. Well, obviously the y-intercept is 3, so this is the point 0, 3. Look, what's this point? This is the point 4 to the right, 3 up. So this is the point 4, 3. What about this point? 2 to the right, 3 up. This is the point negative 2, 3. If you notice anything about this line, the x values are all different. This is negative 2, this is 0, this is 4. But the y values are all the same. As a matter of fact, that's what the equation of this line is. Y equals 3. When you see a equation, a linear equation that has only a y and has no x in it at all, it means that what you have is a line that's a horizontal line. It goes straight across through the 3. All the points on the line have a y equal to 3. And vice versa. If I tell you, say, y equals negative 2, that would be a line you'd go down to. And again, since it has no x, it only has a y, it would be a line, that the horizontal line going through negative 2. And all the x values could be different, but the y's in that line would all be negative 2. What about the slope of that line? Well, let's find the slope of this line. Let's call this our x1, y1. We have anyone, we just have to pick 2 of them, and this is our x2, y2. And let's look at the slope of that line. I'm going to erase this for the meantime because it's just going to confuse everything. Doing the slope formula, I'll get 3, my y2 is 3, minus, let's go, minus 3. That's my y2 minus y1. My x2 is 4 minus 0. So 3 minus 3 is 0, and 4 minus 0 is 4. And we get a fraction whose numerator is 0. Well, if you remember about fractions, anytime the numerator of your fraction is 0, it just means it's 0. It doesn't matter what the denominator is. The numerator is 0 means the whole fraction is equal to 0. In other words, when you have a horizontal line, a line that goes straight across, whose equation is going to be y equals a number, and you'll be able to tell the number by just seeing where it's, what the y value is, that it's going to have just a y and not an x, and its slope is going to be equal to 0. A horizontal line has a slope of 0. Well, that makes sense in terms of what we mean the slope to mean. The slope is rise over run. If you go from one point to another, you're not rising at all. No matter how much you're going to the right, you're not rising, so that your slope is 0 makes sense. And in terms of y equals mx plus b, if you want to write the equation as y equals mx plus b, since your m is 0, you're going to get y equals 0x plus 3, because we know the y-intercept is 3, which again gives us y equal to 3. So this tells us really everything. It fits into what we said about slopes and y-intercepts. If a line is a horizontal line, its slope is going to be 0, and its equation is going to be y equal a number. The number is going to be wherever it crosses the y-axis, and it's going to be that every single point on the line will have that same exact y value. Okay. Let's talk about a similar line, but a little bit different. Instead of a line that goes straight across, a line that's called the horizontal line, what if we have a line that goes straight up and down? let's say I have a line like this. A line that's straight up and down is called a vertical line. A horizontal line goes straight across. Horizontal meaning horizon, so it means straight across. Vertical means up and down. Let's look at some of the points on this vertical line. Well, obviously this point is the point 2, 0, because we're going 2 to the right and we're right on the x-axis. What about this point? This would be 2 to the right, 3 up. So this is the point 2, 3. What about this point right here? I'm just taking points at random. This point, I'm going 2 to the right, but going 5 down. So this is the point 2, -5. What can we see about this vertical line? On a vertical line, all the x values are exactly the same. The y values are different, but the x values are all, in this case, 2. The equation of this line is x equals 2. So when you have a vertical line, you only have x's in the equation, and it's x equal a number depending on where it's crossing the x-axis. A horizontal line has an equation y equals a number, and a vertical line has x equal a number. I'm going to go one step further and find the slope of this line. Let's call this our x1, y1, and this our x2, y2. If I'm doing that, my slope is going to be 0 minus 3, y2 minus y1, over 2 minus 2, 2 minus 2. So this gives me -3 over 0. And we're getting 0 in the denominator. And the one thing you're never allowed to do is have 0 in the denominator of a fraction. You cannot divide by 0. When that happens, we say that's undefined. It doesn't exist. The slope of a vertical line is undefined because it's trying to divide by 0. It's a 0 in the denominator. So horizontal lines have a slope of 0, but vertical lines don't have any slope. Their slope is, we call it undefined, or it doesn't exist, or don't say it's 0. It isn't 0. It doesn't exist. It's a number that doesn't have any meaning. Okay, look out for homework on Delta Math for Thursday. I will see you again on Thursday. Does anybody have any question they want to ask me? I'll stay a few minutes after class. If you want to talk to me, I'll be staying here for a few minutes. Okay, and as Melissa says, 0 in the denominator means undefined.